Hey YouTube, so it has been a while since the last time that I did some stuff for Rover. I want to update because the project changed a lot. It is still my side project. I'm very excited about a bunch of things that I've been doing here. I decided to move it to a completely Lua-ish runtime. Basically the idea is to have what is expected from a runtime, focusing on Lua and leveraging coroutines for doing a bunch of async stuff. I will not explain everything in here. I would just want to show what we can do with it right now. Some stuff that I think that are very interesting, some of the concepts that we're building. So let's just take a look. Here in my terminal, I will just zoom in here real quick. And the first thing is that Rover just a CLI, so you can run it and you can see a few commands that we have. We have the LSP. This is a very interesting one that I will mention later in this video. Rover check. That works similar to the LSP because we can check for errors. It's kind of our AS lint for Lua, formatter, help. Then that's only it for now. But we have a bunch of cool things that will happen. So let's start with very simple stuff. As expected of a runtime, you should be able just to run some Lua code. So I'll just open a file Lua here, just say hello from Rover, and that should be enough to run the file. So if I just do this and run the file, boom, we have the run hello for Rover as we are expecting if we run it from just the Lua itself. Nothing very impressive here to be shown. But let's move on. I/O works the same way as it should work in the Lua stuff. So if you create a file like I/O open, I'm just call this sample in a write mode, and if you try to write hello, I'll just say hello and close the file. You can already see something interesting that is happening, which is thankful for the LSP, because I'm not running the Lua LS, I'm running the proper Rover LSP. Because one of my ideas with the project is to work completely in type inference, but in a type inference based on code flows. So the code should be, the type system is aware of your intention. So this is one of the concepts that I want to bring here, is that we keep a dynamic language, but we make it more safer in some specific ways of work. So for example, here you can see that the file, it can be a table or it can be nil if we have some issues by trying to open the file. So what we can do here is that we can use a search and we can just say f is different than nil. By doing this, the error is gone. This for sure is a table. As you can see here, the code keeps working. So we could just say rover main.lua, and then if I get the sample, here it is. Nothing special happening here except from the LSP. Another cool stuff about this LSP thing that we are building is, let's say we have a function called foo. Actually, let me call it double. And then we receive some parameter, all right? And then you just return the parameter multiplied by 2. If I print this, right? If I run it, we have the 8 value here because everything's fine, like we have the proper values. If I put here a string, that's fine. For this function, that's fine. Lua will interpret it and things will just work. But one cool thing is that here, in the same way that we have this assertion to make sure about our types based on our code flow, we can do the same thing here. So I can say assert type of P is a number. By doing this, I am inferring the type system already needs. So if I hover the function, I know that it's a number and I expect to respond as a number. So the only thing that happens is we have it here. If I try to run, it will keep running. But we have now an actual error because of the type. So the run, I didn't have to create anything else because the type system is being inferred by the code assertion, and the assertion is something that will fail in any regular Lua code. It is just a concept, it's a way to work that we could make things more explicitly. I know that's not a good idea to have errors all the time, but sometimes it's good, like for preventing you from yourself. So this is one of the ideas with this kind of approach. And that will work for anything. So if I just type this as a string, for example, we have the error right here. That's this is a string, so we should not be able to multiply that. It could fail. We need for sure use it to number to do some stuff and the kind of thing, right? Cool. This is one of the concepts of the Rover LSP and how we can enhance the code intent and make the intent of your code flow, the type system, more reliable. Because like the TypeScript system, it's not 100% reliable because it's kind of strong comments and sometimes it is bad, and you have all those crazy gymnastics happening in TypeScript sometimes. The idea here is that your code is really something that you can rely more, even using a dynamic language. I'm taking this inspiration mostly on how Elixir are doing things. Of course, Elixir is way more predictable since it's functional programming, and Lua has a bunch of ways of doing stuff since it's multi-paradigm, but I think this is important to mention. All right, cool. Let's talk about the server itself. I think this is one of the coolest things that we have done so far. If we do an API from Rover, the LSP already understands the Rover itself, and we can start a server. There are some things that we can do to make it better, but you guys will get there. So if we just do this and return an API and we run Rover, automatically the code understands what you are trying to do, because this is it's a battery included that we have in Rover, and you have logs to understand where it is serving. By default, it's the part 4242. And one very cool thing is that you have docs available. So if you click here, you have a full scalar API. This is open API, by the way, that you can use. And of course, we don't have any API endpoint here for testing because we just started doing it. Okay, so let's add an endpoint here so we can start to see the power of Rover. The battery is included with it. So the way that I decided to do this was based on functional extensions instead of the way that a bunch of frameworks usually do that. In my opinion, that's a very neat way of doing stuff. So we can basically say that our API will have an endpoint. I will just create and reload with the method get. And then we'll just return it from the API itself, a message, hello from Rover server, right? That's it. Let's close it. Let's run Rover again. Again, we can open the docs. And now that we have the docs, automatically we can see here that we have our endpoint. We can just go here, test if we want, send, and boom, we have the reload from Rover server as we expected. Another cool thing here, you may be wondering how we can use path params, for example. So, yep, we can do that by just going here and say that we have a P. That is the best I could do since Lua doesn't allow any specific characters, so it's only allowed letters, capital, lowercase, and underscore. So we can just say, let's say hello name, and then we can grab this information from the context. So we can do this like name equals context. IntelliSense is working for some of this stuff. So we have params, and here comes the coolest stuff ever. We have IntelliSense to understand what are the params that we have based on the convention. So I can save it here, and then we have the name. But if we change it for something else, like let's say I type in name, it's saying assessing non-existing path param name. This is very cool. This is something that would help a lot to understand what we have in our API. Another cool thing, we can hover it and we know that this is a get with the reload, hello, then we have this context param, we have a param called name, and this returns a response 200. So let me just paste it here, put a name here. I will just say hello for the name of the person that we're talking. Also, I run that again. And at the reload, I can see that it expects a name. I can run it here. Then I can just say that the name is, I will put my name here, Thales. I can send it and then reload from Thales, and that's it as we expected it to be. That works. As I said, most of the things on Rover and the way that it works is based on code intention. So if you intend to do something, I assume that this is what you want to do in the project itself. So for example, instead of using this way, let's not only grab the name, but let's grab the age. For example, but the age will came from a query param, right? So we'll just go here, save it, and this is the only thing that we do, just adding this here. And I will just do if age is bigger than 18, then I will return, actually I'll just do, if it is less than 18, I'll just return an error here. This error will be, let's go with the 412, you are not allowed here for any reason that it could be. So let's run Rover main. Now look at this. When we run it, we know that this API may return an error with the status 401. This is based on the things that I code. So the code intention generated the docs automatically. I didn't have to do anything else. It automatically understands what is my intention here. So I can say like Thales, and I can say that the age is 26, and when we run it we can see an error, and that's expected because we are trying to compare based on a string. By default everything is a string, so the type system here, there is room for improvement of course, but basically if you put a 2 number here, save it, and run it again, we should now have something working as we have. This is basically the idea how we can work, a lot of cool things. The coolest one that I really want to show here is that we can have, for example, users, and I have a get for users. So I get return API JSON, I return my users here. I don't have a user, so let me just create a variable here because we don't have persistent yet, but I have a very cool idea about the persistence. And what we're gonna do here is that we have a user's post as well. So what we're gonna do here is just a message. That's the only thing that I will do for now. But how we do that to get the user, the same thing. It's context.body, JSON, and that should be enough to make things work. So I can just do table insert as a really regular Lua code here, nothing special. I can just run it, save it. We have a post, this post expected body with an empty object, and that makes sense because I know that I need the body, I know that the body is a JSON. I know that essentially I can paste anything here, so I can do like name, Talus. Let me save it, message okay, which makes no sense. I can send as much as I want here. Then when I go to the get, I can see all the registration that I did because this is what we expect from a post. But there's a very cool thing that we can do here. There's two actual things. One is that by default, it's nice to have a sort of validation as easy as we could be based on the code intents. We know what we expect our documentation to be as well. So one cool thing that we can do is that we can have a expect here, and I expect the body to have a name, and then I can use something which is a guard. Rover has guards in a very similar way of how in the JS world is like this odd, this kind of validations. But basically I can say that this should be a string, and I really expect that to exist. So that's the only thing that I need to do, and look what happens at this moment. When I reload again my documentation, I know that the body has a name. If I try to pass it without a name, I can see an error saying that the field name is required, and that's it. And my frontend can do whatever he wants with that. If I try to paste a number for any reason, I can see that it must be a string. I got an integer. So this is a very simple way that we could have any sort of validations in our code. I think that's pretty neat because now things are just working again, and I can test it again, and things are just working. There's a bunch of cool things that we still need to do, but I think that's the very basis on how Rover do stuff. Code intent, a lot of validations, error handling out of the box for you create any kind of server as you want it. I think that's pretty much it. There's a lot of cool things that I still think that Rover should have that's still work in progress. So for example, the UI stuff. I really want to make a UI that would work over the web and for the mobile stuff, because it started as a mobile project, and then I decided to make a full ecosystem for Lua mainstream development. Instead of going in the same direction as everything does for JavaScript world, I decided to go in a way that is more Lua-ish for real, because Lua is lightweight, Lua has coroutines, the way of working is very different because everything that you do, you imagine as is the sync stuff. Sync, not as async, but you can do things in a certain way that is async based on the coroutines usage. And there's one more thing that I actually want to show here. One thing that I was really doing that was very excited about it was related to benchmarking it, because I really focused on trying to do that as the best as I can comparing to the main platforms that we have. So what I did here is I have a comparison of a benchmark test that I did for throughput and latency. And as you guys can see, I compared here Bun, Dino, which is the most, I will not compare that with Node, I think that's unfair. Bun and Dino are the top JavaScript runtime in the market right now. I do believe that we should compare it in this situation because Rover is a single thread yet. It runs a bunch of Lua, there's a bunch of strategy with polling. I will make another video just talking about the performance optimizations that I did so far and some other stuff that we could do to improve that as well. But I decided to compare with the base HTTP Go library, the fast HTTP, which I know is way better, and compare everything with Rover, and you can see Rover is here in this line. Slightly better than Bun in most of the cases, but when it got in the more high load, it started to get a little bit down here. I'm still investigating and trying to make these things better because I know like it just started to make this full stack servers thing, and I think that there's a lot of room for improvements. And here's the latency as well. We can see that until the 1000 connections, the latency is slightly better than Bun most of the time. Bun is slightly better, but here this graph is the less the better, the biggest the worst. I don't know why Dino was so bad in my tests. I did the exact same test for all the platforms. Bun was very superior. The default Go library was not that great, but the fast HTTP is so good. But again, comparing with interpreted languages that are way simpler to be written, well, are the results as you guys can see it. One more thing that I want to mention is related to what I imagine when using this for LLMs. The way the Lua works is that we have only 21 keywords to be used in the language, and it's a very simple language if you think about it. So in my mind, I think that maybe if we do some stuff focusing on LLM, maybe some fine tuning, I don't know, still guessing some ideas here in my head, I think that we can leverage the power of local LLMs. I mean, the small models for specific Lua codes, and following all these conventions and doing a better tooling, a better LSP, a better check of how the things work, that would make Lua way better to use, and the mainstream would look at Lua with better eyes. And I think that's it. Thank you for watching. If you have an idea, any suggestion about the project, let me know. I will add the links in the GitHub. And I started Vibe coding, the list of docs for that, but it's not that great yet, but I will leave in the description as well so you guys can take a look. And that's it. Thanks for watching, and see you in the next one.